Alright folks, thanks for coming. Today we're gonna start dealing with polynomials. It's gonna be polynomials in one variable. I will only deal with one variable. We're not gonna spend too much time on this. It has a lot of terms to be defined. I'm gonna define the terms, work a couple of examples, and then we'll leave it there. When I get to college algebra, that's algebra 2. When I get there, I will treat this in more details, okay? But anyway, what is a polynomial? Before we start, please subscribe to my channel, like and share this video, leave comments or questions under the video. I will get to them. What is a polynomial? We've been dealing with a polynomial. Yeah, you guys, you will know why. When we dealt with a linear equation in one variable is a polynomial. A linear equation in two variables is a polynomial, right? So all along we've been dealing with polynomial. We just didn't say anything about that. But over here in this video, we're gonna generally define polynomial, and then we show you some examples. But it's a lot of terms to remember. They're not difficult to remember. You just have to put an effort. You see what you're looking there? You're looking at there. You have two different bikes. Okay. Well, this one is called, this one right there, the first one right there, this one is called monocycle. You probably seen that before. Monocycle. They will help you to remember, to understand what we're doing. It only has one tire, right? And then this one here is called bicycle. Bicycle. Okay, because it has two tires. Bi means two. Mono means one. And then look at this one. This one is called tricycle. Tricycle. You know what that means. It means three tires. See? 1, 2, 3. This one got 2. And this one got 1. So mono means 1. Bi means 2. Tri means 3. We're going to have the same thing called monomial. Okay, see that? Nomial. And then we're gonna have binomial. Binomial, okay? I hope I'm spelling it right. We're gonna have trinomial. Alright, we're gonna have all that. Okay? Trinomial has three terms. Instead of three tires, we'll say terms. It got 3 terms. This one got 2 terms. Alright. And this one got 1 term. Okay. All that stuff will be clear to you as I go on. First, I need to define what is a polynomial. Like I said, we've been working with polynomial since we started. But we just didn't define it generally, So now I will define what is a polynomial, and then we'll move on from there, okay? Alright, I showed you those bikes, right? Monocycle, bicycle, tricycle. See the word poly. Poly means many. Nomial means term. Polynomial basically means many times. Many times. Polynomial, many times. Okay, that's all that literally means, many times. But how many? Well, it can have 1, it can have 2, it can have 3. Okay? But I'm going to formally define it in mathematical way. Alright, let me define it in mathematical way. But anyway, the word polynomial means many times, okay? Alright, okay. Here is a formal definition of a polynomial. A polynomial in one variable, right? One variable x. This case we're using x, okay? It's an expression of the form an times an times x raised to power n plus a to subscript n minus 1 raised to power times x raised to power n minus 1. I will explain all that, and then you keep going until you get to a subscript 1 times x raised to power 1, and then you get to a subscript 0 and then times x raised to power 0. You see why this is why I had to deal with exponents first. Notice that this one is the same thing as a0, right? Some books will write it like this. We'll replace that with just a0, because you remember anything raised to power 0 is 1, okay? Alright, so that's why I had to deal with exponents first. Basically what they're doing there is they say a is a constant, right? Well, see what they say, where a is a subscript n, a subscript n minus 1, keep going. These are all constants, and not all of them cannot be 0, okay? And then it says the power n, right? N and whatever you have up there, n minus 1, and keep going. They have to be positive integer, okay? It has to be positive. You cannot, I will explain that. I will explain that definition and zero, but let's try to see what it says. Just look at it, what it says, man. You see that? Okay? Look at it carefully. You have a constant, multiply x, and the x is raised to power some n. Okay, then it goes like that. See, when you see a polynomial, it doesn't have to have all the constants, because this is just the standard form. You may see one that is not in standard form. It may have 2 terms, it may have 1 term. So but notice this too. It says this has to be positive. That means it cannot be negative. You can't have a negative power. Don't let that confuse you. That's just, it starts here, then it decreases, okay? So that means it has to be, the power on x has to be positive. Cannot be negative. You can't have a negative exponent. That's all that means, man. Okay, so let me give you an example of what is considered a polynomial and what is not considered a polynomial. Okay, that way it will help you to understand the definition. Now check this out. Something like this. Well, let's start with this. You remember we dealt with something like 5 minus 4x. This is a polynomial. It's just a linear equation, but it's a polynomial, okay? What they call linear polynomial. And look at this one, x plus 7x raised to power 2. This is a polynomial, but it's called quadratic. This one is called linear polynomial, okay? This is quadratic, okay? We're gonna deal with the quadratic equations later. This is called quadratic. Sorry, it's called quadratic, okay? All right, and then notice what that thing says, man. It says that well, look at this. This is a polynomial too, and this here is a polynomial. I'll give you an example. That one is linear polynomial, and this is a polynomial. Something like 7 y raised to power 3 minus 9 over 4 raised to power x. See, this is a polynomial in 2 variables, but we're just gonna concentrate on 1 variable. So let me just do it like this. We'll do it like that. Y raised to power 1. This is raised to power 3. Okay, so these are polynomials, right? Well, you can say raised to power 2. That way I don't confuse you. This is a polynomial. 3x plus 3x squared minus 0, 1, you can say 0, or you can say even 0x. I'm sorry, 0.x. It's 0.x is like 1x, okay? So plus 0.6. These are all polynomials. It's not breaking any of those rules, definition given. And this is a polynomial. 7, 12x 5 plus 9, 6x 3. This is a polynomial, okay? So I will explain it more as we go. This is a polynomial, like I said. A constant can be a polynomial. Just a polynomial in one term. 7 considered a polynomial. That's allowed. That thing is a polynomial, man. It's just one term. This is a polynomial. That's a polynomial, okay? It didn't break any rule given in the definition. But here, these are not polynomials. That way, you're not polynomials, okay? Watch this. Not polynomials. These are not polynomials. Something like 6y raised to power 4. See, you can't have that. You can't have negative exponent. See, now you see why I had to deal with exponent before polynomial. If you have negative exponent, then it's not a polynomial, okay? Or something like this, like 6 divided by x plus 3, it's not a polynomial because you can't divide. Here, no negative exponent, okay? No negative exponent. No negative exponent allowed. It's not allowed. Yeah, it's not allowed, okay? Here, you can't divide with a variable. If you divide with a variable, then it's not a polynomial. Yeah, never. Well, let me say it this way. I don't want to say never divide, but I say division. Division with a variable, okay? With a variable, not allowed, okay? You can't do that. You can't divide with a variable in polynomial, okay? And then this is not a polynomial either. This thing here, 1 over x is not a polynomial because you remember this can be written as x raised to power negative 1. That's not a polynomial. And then x divided by x squared. It's not a polynomial. Recall what we said. This is something as x, then x raised to power, remember, 1 over 2. I don't know if you remember that this is like that. It's not a polynomial because it's negative, okay? See, that's why I had to treat exponents first. You remember there was a rule I explained to you. There was a rule when we did exponents says that if you have something like this, it can be written as, well, if you have n here, it can be written as x raised to power 1 over n, right? Alright. And then if you have n like that, all multiplied by m, I remember I told you that it's x m over n. So these are you can't have that. These are negative exponents. Actually, this is well, I know this is a negative exponent, so you cannot divide. Actually, this is okay, but here I know this one you can't divide because this is negative. When you have anything like that and like that, it becomes negative. See, but don't worry about this. Sorry about that. So you can't divide it. You can't have a negative exponent in polynomial, okay? So that's what is going on there. Now we'll have more terms to define. So I gotta give you more definition. Just follow it, slowly and keep going. You will understand all that stuff. You just have too many terms to define. All right. I want to talk about variables, okay? When it comes to polynomials, we're dealing with polynomials in one variable. So, like I said before, this can be a polynomial. 55 can be a polynomial. Notice there is no variable, okay? It has no variable. That's okay. it has no variable. Okay, that's okay. So that's a polynomial. Okay, it's a polynomial. Okay, now what of this one here? Well, a polynomial can also have it can have one variable. Okay, one variable. That's what we're working with. Its example is like something like this: x raised to power 3 plus 6x raised to power 2 plus x. Okay, it's just one variable. Make sure you understand what is going on there. This is a 55 is a polynomial. This is a polynomial in one variable. Okay, so only the variable there is only x. Don't confuse the powers, the exponents with variable. Okay, now it's a polynomial with two variables will look like this. Two variables. So you need to understand all this stuff, man. Two variables will look like, it will be like x raised to y raised to power 3 6x plus 7y. Notice that it has two variables. It has y, then it has the x. You see, it has x and it has y. Those are two variables. The two variables are x and y. Okay, but we're not gonna deal with polynomial with two variables. We're just gonna do polynomial with one variable. Okay, it can have more than two variables. Okay, a polynomial can have let me see, more than two variables. Okay, you can have more than two variables. Something like x y raised to power 2 plus 7z raised to power 3 plus 6t. Notice that this is a variable, this is a variable, this is a variable, t is a variable. That one got 4 variables, man. So like I said, we're only gonna deal with a polynomial with one variable. That's what we're gonna deal with. Okay, so that's something for you to know. Okay, let's talk about names. Let's talk about names. Polynomials have special names. Okay, like I showed you at the beginning. Remember the bike? You have a monocycle, bicycle, and a tricycle. Polynomials are like that. Polynomial can have what is called monomials. There are binomials. There are trinomials. Okay, monomials only got one time. See, those are examples on the left, right there. This is a monomial. See, this is one time. That considered one time. This is one time. This is one time. You see that, right? So these are each is example of monomial. Now look at this. Binomial has two terms. You see right here, this is one time, this is another time. So you got two times. This is one time, this is another time. You got two times. You see that, right? Compared to the monomials. Monomials only got one time. It doesn't matter if the time has a constant multiplied by a variable. Alright, so in this case, you see that, right? Okay, look at the trinomials. It got 3 times. You see that? One time here, second time here, this is the third time. The same thing here, this is another example. One time, another time, 3 of them. And this one here, one time, another time, 3 times. Okay, so that's how you understand that. Don't get confused. Separate the names from the terms. Okay, always separate the names from the terms, then you should be okay. Okay, let's talk about degrees of a polynomial. Okay, a degree of a polynomial, right? A degree. Okay, a degree of a polynomial in one variable x is the largest exponent of the variable x. Okay, so what is that saying? What is that saying? Well, here is what it's saying. Let me give you an example. 6x plus 4 is a polynomial, right? It's a polynomial with 2 terms, but notice it's a polynomial with 1 variable. I'm sorry, with 1 degree. 1 degree, because the highest degree there is 1. It's on x. Look at that. The highest degree is x raised to the power 1, but we don't usually write it. Okay, we omit that when it's a degree. The degree is 1. Okay, look at this one. Look at this example. 3x x raised to the power 2 plus 6. Okay, it's a polynomial. It has 2 terms, but it has 2 degrees. You see it, right? 2 degrees, right? The degrees is 2 because you see x has 2 exponent 2, so it's 2 degrees. You see it, right? Okay, look at this one. Suppose we say 8x raised to the power 3 plus 7. Again, this is a polynomial with 2 terms, but it has 3 degrees. Okay, the degree there is 3 degrees, because in x has the exponent 3. See that, right? Okay, now what of this one? Let me give you this example. X raised to the power 5 plus x plus 32. Okay, even though it has 3 terms, right? Because this is a term, this is a term. There are 3 terms, but it got 5 degrees. Okay, you see that, right? 5 degrees, because x is the highest exponent there is 5, so it's raised to the power 5. X is raised to the power 5. The highest degree on x is 5. You see that, right? That's all how you determine the degree. Let's say you have this. Let me give you one more example. You have let's say 10x raised to the power 10 plus x raised to the power 9 plus x raised to the power 8, plus 7. What is the degree there? It's not this one. It's not that one. It's this one, because that's the highest degree there is 10. So it's 10 degrees, okay? Because the highest exponent there is 10. So you see how to determine the degree of an exponent, okay? The highest one overrides the rest of them. That's how you determine the degree. So make sure you understand that. Alright, here are the algebraic operations you can perform with polynomials or polynomials. You can add or subtract polynomials. Okay, you have 2 polynomials, you can add them, you can subtract one from the other. You can multiply 2 polynomials. You have 2 polynomials, you can multiply the 2 of them. And then check this out. If you have a polynomial, you can multiply that polynomial with a constant. You remember we did that when we did when we did a linear equation is a polynomial. So you can multiply the whole equation with a constant, okay? And then check this out. Division with polynomial is kind of tricky. If you divide a polynomial with another polynomial, you may end up with something like this, like 6 over x. You can't do that. You can't divide with variable. So that's a problem in polynomial. So when you divide one polynomial with another polynomial, it may or may not be a polynomial. It may end up being not a polynomial. Okay, but see, when you add or subtract 2 polynomials, it's always gonna be a polynomial. Okay, so the result is gonna always be a polynomial. Okay, when you multiply 2 polynomials, right, you're always gonna get a polynomial. Okay, when you divide, but you see, when you multiply a polynomial with a constant, likely it's a polynomial. It's not likely. I'm sure it's gonna be a polynomial, just a constant. Okay, but division it can be a problem. If you divide a polynomial with another polynomial, it may not get a polynomial. Okay, and then another thing about polynomial is graphing. polynomials are very useful, man. You will see later. You can graph a polynomial in one variable. You can easily graph it. You're probably seeing graphs like this. It goes like that. These are polynomials, okay? They are polynomials in one variable. This is x, this is y. I'm sure you're seeing graphs like that, like that. You're seeing graphs like that. These are polynomials, man. So polynomials are easy to work with. Especially polynomial in one variable, okay? So always keep that in mind. If you keep that in mind, you're not gonna go wrong. I'm gonna formally show you what this addition and multiplications are, but when we do the examples, you get them, you become familiar with it. All right, check this out. If you are given, okay, you are given two polynomials, right? And this is one of them, and this is one of them. Then you can sum them. You can sum them like that. P plus Q. You sum them up. Remember, they are in the same variable, okay? They are in the same variable. You see that, right? They are in the same variable. You can sum them. You can do the difference of two of them. You see it right there. You just move out the. It's like you isolate the variable, then you add the constants, okay? Just look at it carefully. You can multiply one of them with a constant k. If you multiply one of them with p, polynomial p with a constant, p, let me see. Yeah, if you multiply p, p is a. P has to do with a, well, let me change this. If you multiply q, with a constant, then you multiply each of the constants in the polynomial with k, and then the variables you multiply the constant. Terms with variables, right? You multiply the constant next to them with k, and then you add the variable next to it. That's all what is going on there. And then the same thing, you can multiply two polynomials right there. You multiply them. There are a lot of stuff involved. You can use for. Remember what they call for? Like if you have a multiplying ax plus bx, you multiply it with another something here, 2x plus 3x. You use for. So you multiply that you multiply with that. You come back, you take that, you multiply with that. That's what is going on there. So you use for to do the multiplication. So these are just generally, I'm giving you general ideas what you can do with polynomials. So you can sum them. You can subtract one from another. You can multiply a polynomial with a constant. You can multiply two polynomials, okay? So I'm gonna give you examples of each of this stuff. All right. Okay, let's talk about coefficient. You see the way I wrote that. I talked about it before, but there's a couple of things I want to say. See how I wrote that? We can also rewrite it as this. See, this is over here is the polynomial have degree. The highest degree is n. All right. We can rewrite it like this, okay? That's how I wrote it before. It doesn't matter how they write it, you can always figure it out. I can write it as n. See, they went down this way. I can write it. I can go up with the times. X, the highest degree is right there. You write that first, and then you write the next one, n minus 1. Okay, x n minus 1, like that. You keep going until you get to a0, okay? All right, you see that, right? So there is a couple of terms. As like I said before, these are the coefficients, all right? They call these coefficients. That's a coefficient. Actually, here is x raised to power 0, which is the same thing as 1, right? But there's something I forgot. There's something called the leading coefficient. Leading coefficient, all right? And then leading term. You know, that's what they say. I don't know why they call them that, but leading term. Okay, so there's something called leading coefficient and leading term, okay? You know, we talked about constant term before. This is a constant term here because that thing is equals to 1, okay? So, the leading term is the leading coefficient is the coefficient with the highest, in this thing here, the leading coefficient is an, okay? And then the leading term is this, anx. You know, in other words, the leading term is the term with the highest degree. Basically, where the degree of the polynomial is. We don't say highest degree, but that's the highest exponent, right? Because if you have a polynomial, there's something called the degree of the polynomial. The degree of the polynomial is the highest exponent. So the leading term has the highest exponent, okay? And then from there, the leading coefficient is associated with the leading term. You see that, right? This is the leading coefficient is associated with the leading term. You see that, right? Because if you get a leading term, there's a coefficient to it. That coefficient is called the leading coefficient, okay? That's all I was trying to explain. Something called the leading term, the leading coefficient. That's important because you will see when we start solving problems, okay? Alright, let me give you the following illustrative example, okay? See, that's a polynomial right there. You see the polynomial right there, okay? So, they want to know what is the degree of that polynomial. Okay, I hope you'll be able to determine that. Look at it carefully before I start solving. Alright, look at it carefully. The degree of this polynomial is basically 6. See right there, 6. What is the constant in this polynomial is 4. See right there is 4. What is the linear part? That's a linear equation in this polynomial. See right there is this one, 6x is the linear because it has one exponent. Okay, exponent there is 1. What is the leading term? The leading term is this one here. The leading term is 8x raised to power 6. The whole thing there is the leading term. What is the leading coefficient? The leading coefficient is found in the leading term. The leading coefficient is 8. You see it, right? So make sure you understand this, man. Make sure you understand this. I just made up this example that way I can explain all these terms, okay? Alright, you see it, right? And notice that the polynomial has only one variable, okay? You know, so I just want to use this example to illustrate all that stuff I just talked about, okay? Alright, so let's find some problems to solve. Alright, so I almost forgot this. There's something called 0 of a polynomial, right? Do you remember when we did linear equations in 2 variables, right? I mean, linear equation is like a polynomial in 2 variables. You remember when we draw the graph? You remember we dealt with something like this: y equals to mx plus b, right? Where this is the y-axis, x-axis, y intercept. This is a polynomial. It's a polynomial in 2 variables, but it's a polynomial with degree 1. Okay? So, to draw a polynomial, you may not always have it like this, have it simple like this. To draw a polynomial, there's something called the zeros of the polynomial, right? You get the zeros when you take the polynomial. Okay, if this is a polynomial, I'm going to write it generally. This is a polynomial. You find the zero when you take the polynomial x and you equate it to 0, and then you solve for the for x. Okay, in this case we usually get x. We can get x equals to something, equals to, let's say, t, right, where t is a constant. So in that case, t is called the root. T is called the root of the polynomial. Okay, the root or solution. Sometimes they say the root, but it's the same thing. We've seen that before. It's called the root or solution of the polynomial. Okay, sometimes it may not be one. It may be a couple of them. All right, maybe a couple of t's. T, maybe t1, t2. Okay, t3. So t is called the root or the solution of the polynomial. Okay, you find t by taking the polynomial and equating it to 0 and then solving. So I wanted to make sure you get that. So knowing the zeros, when you have a polynomial, knowing the zeros allows you to draw the graph. Remember, that's what we did here. Remember, that was also we did they gave, when we were given a linear equation in two variables. Remember, we use x-intercept. We use x-intercept and y-intercept. We'll find them, and then we use them to draw the graph. X-intercept, you find x-intercept by setting y equals to 0. You find y-intercept by setting x equals to 0. So that's the same thing. That's the same idea here. If you set the polynomial equals to 0, then you find that particular constant that solves the equation. That constant is called the root of the polynomial or the solution of the polynomial. Okay, just keep that in mind when we're gonna use that a lot when we start solving problem. Okay, let's look at more examples. What we're gonna do, we're gonna examine the terms of the terminologies, and then we're gonna do probably addition, subtraction, multiplication with a constant, multiplication of polynomial, and then we'll end this video there. Right, in the next video I'm gonna deal with what is called factoring. That one is involved. That should be one video, so that way we can finish this video and then do that video later. Okay, now you see what is given here. It says if you look at the polynomials, it identify the terms, right? The terms that go with it. It's a bunch of terms you can identify. Leading term, the what do you call that? The degree, the constant term, all that stuff. Okay, so we can look at that. If you look at it, it has a lot of information there. See the way they wrote it. You can rewrite it like this. That way, you can rewrite it like this: 5x raised to power 3 plus 8x raised to power 2 plus x. Okay, so notice there, if you write it, you don't have to write it like that. Notice that's the leading term. Okay, the leading term is 5x. Okay, 5x raised to power that, and then the leading coefficient. Okay, leading coefficient. Leading coefficient. Okay, leading coefficient is 5. The degree of that polynomial is 3. Okay, there's no constant term. He doesn't have constant term. The linear thing there is x. Okay, all right. So see, we can find a lot of stuff there. If you look at it carefully, there are a lot of stuff there. So all right, let's go to the next one. See the next one. What is the, look at all the terms. Again, the leading, I should have given myself a nostril. Leading coefficient, okay. Leading coefficient is -19. The degree Degree in that polynomial is 2, and the let me see, the degree is 2. The leading, the leading term, of course. If we can find the leading coefficient, the leading term. The leading term is 19 x raised to the power 2. Okay, see, the linear thing is just x. Okay, so let's look at the other one. Again, this one here, the degree, right? The degree is 3. The leading term is what? 2x raised to the power 3. Okay, and the leading coefficient. Oh man, hang on a minute. I didn't give myself enough space. Leading coefficient. Leading coefficient there is 2. Okay, all right. So basically, those are the stuff we need to. This one you can rewrite it if you want. You can rewrite it in standard form like it. Let me see. Negative x raised to the power 7, negative 2x raised to the power 3, and plus x. If you want, you can. If you don't want to, you don't have to. Now notice this thing, the leading term. Okay, leading term is negative x raised to the power 7. Okay, the leading coefficient, it has one. Leading coefficient is -1. You see it, right? And then the degree of that polynomial is 7. Okay, the linear part of it is that. Okay, how many times? Yeah, how many times of that polynomial has got 3 times? Okay, I forgot that, 3 times. What of this one? Let's go back. This one has how many times? 1, 2, 3. This one have 3 times. All right, and this one got 2 times. Okay, 2 times. And this one here got 2 times. Okay. All right, so we'll talk about that one already. All right, see that, right? Those are the stuff you may need to know. You need to understand, though, that way when we start adding or subtracting or multiplying or multiplying with a constant, you will know exactly what you're doing. Okay. Okay, let's look at these examples here. He says you need to simplify it. If possible, just combine into one term. Okay, you remember what is a term? A term in polynomial, this is a term and this is a term. So this polynomial got 2 terms. Okay, so they just want you to simplify it. Okay, so if possible, combine them into one term. So let's go. What is that? That's let me see. You see, it has common powers. So look at the powers, and then you see you can combine them. That becomes look at the constant -3 plus 5. That becomes 3. No, it becomes 2. Sorry, 2x right raised to the power 5. I think we're done there. You see, you can combine that. You just have to eyeball it. Because you see, the trick is see if they have the same time. It's like you have 2 oranges plus, you have 5 oranges and you're subtracting 3 oranges. It's just 2 oranges, okay? That's what we just did there. So this example will help you to, keep your eyes on the board, see what is going on in the polynomial. Look at the second one. Look at that one. That one again has 2 terms. And look at the power. It has the same, it's one variable, the same power, so you can combine that. You combine that. What is that? Look at that. You see that it's minus x raised to the power 5. That's it. You see that, right? Make sure you can see that. If you just use your eyeball, try to combine it. If you try to combine it, you should be able to do it. All right. I hope you see that, man. If you don't see that, I mean, I don't know how else to explain that. If you don't see that, you can write it like this. As I'm talking now, I'm thinking. You can write that like this. Write it like this. 2, right? 2 plus, oh, I'm sorry. You can write it like this if it helps you. 2 minus 3, all, right? Let me see. All in, what is that? All the x raised to the power 5. Yeah, you can write it like that. So it becomes minus 1 raised to the power, the same thing as minus, we usually don't put minus 1 in the front, the same thing as that. Sorry, the same thing as that, you see. So, if that helps you, that's how I found it. So let's move on to the next one. The next one says, you see that there? Look at the terms. The terms are the same, the same powers, right? The exponent is basically which one do you call the leading term? They all have the same, the same power. I know that the degree is 2. So you can write that as 9, again, minus 19 x raised to the power 2. You see that, right? And then simplify that. What you get is minus 10 right there. You see it, right? It's no more than that, man. So this will help you orient to how to handle this thing. Look at the next one. You see, there are 3 terms, 1, 2, 3, but they all have the same powers. So we can write it like this: minus 3 plus 3 minus 5. Since it has the same term, we'll write it like that. You did the stuff inside the bracket. What do you get? This cancel out. You get minus 5 right there. You see it, right? So you gotta keep your eyes on the ball, man. If you keep your eyes on the ball, this stuff is not difficult. What is that? What did I do? Yeah, that's it. It's minus 5 x raised to the power 5. We did that, man. So if you keep your eye on the ball, you shouldn't have any problem. Just keep your eye on the ball and pay attention to the powers. Usually the trick is to pay attention to the powers, man, because we're only dealing with one variable, okay? Just keep your eyes on the powers, on the exponent. Okay, look at that one. Look at it, eyeball it. It has the same. First of all, we're dealing with one variable, right? So, but it has one exponent is, 2 exponents are the same, one is not the same. So that means you're gonna end up with 2 terms. You see there, right? So you do like this: minus 3 plus 4 raised to the power x raised to the power 8 plus, minus 3. You see that, right? Minus 3x raised to the power 2. So you do that right there. What do you get? You get 2. Not 2. It's 1. So it basically is x raised to the power 8 minus 3x. I think we can't reduce this any further. Well, I guess we could. There's a trick, but I don't know if they want us to do all that. You see that, right? But we'll leave it like that. I think that's all they want us to do. Now let's go to the next one. This one here. What does it say? Look at that carefully. It says that it says that it has the, look at that, look at the exponents. Again, we know it's one variable. There are how many times? 1, 2, 3, 4. The polynomial has 4 terms, but so what? The exponents, if the exponents are all the same, because we only have one variable. If the exponents are all the same, then it makes your life easy. So you can do like that: 4 minus 4x in bracket plus 3. Minus 4 plus 3 minus 2 plus 1. You see that, right? And then x raised to power 2. That's the same thing as you start simplifying this, okay? So that would be, I mean, you don't want to make mistakes, so you can do it like this: minus 6 plus 4, okay? X raised to power 2, and then it's minus 2x raised to power 2. You see that, right? You know, so you can do it like that if it helps you. That way you can see. All right? Okay, let's go to the next one. You know, look at that one. It said, look at the exponents. You got the same exponents, man. So we're dealing with the same thing. We can simplify that. Again, you see, we're dealing with one variable. It's like, let me read it differently. It's like you have 3 oranges, you subtract 8 oranges, you add 1 orange, you add 2 oranges. That's all. 2 oranges or whatever. You know, so what you do is say 3. I'm sorry, not like that. Sorry, I'm going too fast. 3 minus 8 plus 1 plus 2x raised to power 5. You see it, right? You know, if that helps you to see it, let me see. Then it's like 3. No, not 3, sorry. Combine all the positive. That would be 3 plus 1 plus 3 is 6 minus 8 x raised to power 5. What is that? That's negative 2x raised to power 5. You see it, right? It's not more than that, man. You know, so that's what is going on there. Just keep your eye. This will help you to deal with polynomials. When you do problems like this, it helps you to orient you. What are you looking for? You're looking for the exponents, man, because we're dealing with one variable. You see that, right? All right. Look at the next 2 examples. They involve a bunch of fractions. I chose them carefully. That way you can see that there's nothing to be scared when you're working with fractions and polynomials in one variable. So you always keep your eyes on the variable, the exponents on the variable, okay? All right. So how do we tackle that? We'll do what we've been doing, okay? You isolate the variable. That way you can see what is going on. It's good that it has the same powers, the same exponent. So you say minus 1 over 3 plus, put that in bracket, plus 2 over 5, all right, plus 1 over 15 minus, what is that, 8 over 5, all times x raised to power 7. You see that, right? I just pulled the x out. I pulled the variable out. You see that? Notice that we can combine all that stuff, man. We can combine all that stuff. If you remember, we can reduce all this to, all of them can be reduced. The denominators of all those fractions, we can make them become 15 each. That way we can combine them. You remember our trick? We'll find a way to multiply each term. That way we can reduce the denominator to 15. So the first one, what do we need to multiply? We will multiply with 5. If you multiply 3 by 5, you get 15. So you say 5 over 5, which changes nothing, okay? 1 over 3. You see that, right? And then we say that one is 3 over 3. Again, 3 over 3 changes nothing because you cross out, becomes 1. Okay, see that again, right? It's that one we don't need to do anything. Okay, the next one we oh, that's minus. Sorry, you gotta keep your eye on the ball. Minus 2. Let me see. Actually, it's 3. 3 over 3 changes nothing. 8 over 5. You see that, right? All that thing is in x raised to power 7. You see that, right? Okay. So let's work with these fractions. So you have minus 5 over 15, all right, plus what is that? 6 over 15 plus 1 over 15. You see that, right? Plus What is that? 3 times 8 is 24. 24 over 15. You see that, right? You see that, right? So then you bring the variable, you see? So now you can combine it because they have the same denominator. So you can, the common denominator is 15, then you say minus 5 plus 6 plus 1 plus, I'm sorry. Actually, let me move it where you can see what I'm doing. I don't want you to get confused. I gotta give myself enough space. That's the same thing as common denominator is 15. They say minus 5, sorry. Minus 5 plus 6 plus 1 minus 24 all over 15. All that x raised to the power 7. Oh Lord. Let's start here. Finish it up here. Minus 5 plus 6 is you get 1. 1 plus 2, you get 2. 2 minus 24, you get 22, okay? So basically it's minus 22 over 15 x raised to power 7. That's what we're looking for right there. It's not more than that, man. It's not more than that. That's it. I kind of took too much space. It's okay, man. So I hope you can see the other problem, the same issue, a bunch of fractions. But look at that. They have the same, you see that? The same exponent, okay? Once you have the same exponent, the rest are easy, man. So you pull out the variable like this, minus 3 over 4 minus 1 over 3 plus 7 over 2 over 12, sorry, minus 1 over 6. You see it, right? Pull it out, and then you have x raised to the power 2. So what we did in the other problem is what we're going to do here. We're going to try to raise everything, put out the denominator to 12. So we use our usual trick. Alright, so we're gonna do 3 times 3. It changes nothing, okay? 3 over 4. And then we're gonna do minus 4 over 4, which changes nothing, 1 over 3. And then we're gonna do, that one stays the way it is. And this one here we'll do 2. Let's do 2. We use 2 to manipulate it. We did 2 over 2 times 1 over 6, okay? All that is, the variable is there. So we simplify. What do we get? We'll get 9, negative 9 over 12, negative 4 over 12, plus 7 over 12, negative 2 over 12. You see that, right? All multiply with the variable. So now we'll have to simplify that inside that bracket there. We'll have common denominator is 12, and then it becomes minus 9 minus 4 plus 7 minus 2, okay, all times x raised to the power 2. So we keep simplifying it, right? You keep simplifying that, and what is that? That's negative 13, okay, plus that one here, so it will be negative 15. Negative 15 plus 7, okay, over 12, like that. Okay, keep going. That would be negative, what is that? Negative 8 over 12, like that, right? Because negative 15 plus 7. Alright, we'll give you that. See, we can simplify that too. So that gives you, divide by 2, you get you get negative 4. Actually, divide by 4, sorry. Not 2, divide by 4, you get negative 2 over 3 x squared. That's what we're looking for, right? So we were patient. If you're patient, you arrive at the right thing. You see, that's what we did right there. Okay, let's do the next two. You see that? I chose this on purpose because you see it got a bunch of fractions, but don't let that, it got a bunch of decimals. Don't let that scare you, because look at it carefully. It's the same variable, but all of them have the same exponent, so there's nothing to be scared of. So you can do it the way we've been doing it, okay? Even though it has a constant out there at the end, you can isolate that too. So you can do it this way: 0.8, okay, minus 0.3 minus 0.5. All right, and then all that stuff has x times x with exponent 4, and then you isolate the 7. You see that, right? So you can add this, man. You can add the fractions. It's not that difficult. Add the down fractions. What do you get? If you add the fractions, let me see. Oh Lord, you notice the fraction adds to 0. Look, 0.8 plus 0.3 is 1. Let me see. What did I do? I'm sorry. You gotta subtract. Sorry. 8 minus 0.3. What do you get? You get 0.7. No, I'm sorry. You get 0.5. 0.5 minus 0.5, you get 0. You see that, right? So basically that says 0 times x raised to the power 4 plus 7. You see that, right? Look at that. So you can write that as oh Lord, see, I told you 7 is a number like that is also a polynomial. If you want, you can write it like this: raised to the power 0. It's still a polynomial. That one is still 1. This is still 1. So you see that, right? So 7, the answer we got 7 is still 7 is a polynomial, man. What I call that monomial. Monomial is a polynomial with 1 term. Okay. So 7 is a monomial, man. It's still a polynomial, you see. Alright? So let's do the next one. What is that? Keep your eyes on the fractions, on the decimals. I'm sorry, keep your eyes on the variable. The variable, the same variable, but it has the same, all the variables, all the exponents are the same. Then you can isolate the 9. So you say 1.2 minus 0.9 minus 0.3 or times x raised to the power 3 plus 9. Isolated over there. Notice that. I think it's the same thing, man. Because if you add a 0.9 plus 0.3, both of them are negative. If you add those, what do you get? You get negative 1.2, and then it will cause that thing to be 0, man. You see that, right? So all this stuff will be 0. So you have 0 times x raised to the power 3, which is the same thing as 0 plus 9. So that's the same thing as 9. Okay, that's a polynomial there. 9 is a monomial, right? Which is 1 time. If you want, you can write it like this. Because that thing will become 1. So this is still a monomial. Monomial is a polynomial. You see that, right? So I want you to do all this example. That way you can get used to working with polynomial we're gonna get to factoring and dividing and all that stuff. We're gonna do that in the next video. This video, let's do a bunch of other stuff. Okay, you see what it says? Find the value of each polynomial when x is equals to 2, b x equals to -1. You see? So what I have to do, I think I didn't give myself enough space. I will divide the page into 2. That way I can do x equals to, how do you say that? X equals to 2 and x equals to -1. So here we'll do x equals to 2 on this side. This side we'll do x equals to -1. So for each, right? Let me move that up the way, man. Just give me a minute. I don't know what I did. I didn't give myself x equals to 2. Okay. So we'll start with that one. When x equals to 2, that becomes 2 times 2 here raised to power 2 plus 5. Let's see. What is that? 2 plus 1. Okay. Basically, if you want, you can say, you can equate this to px, and then you say p, you plug e2 in, all right, and then you get, what is that? It's 2 times 4 plus basically 10 plus 1, that would be 8 plus 10 plus 1, that would be, what is that? That would be 19. That's what we got there. So we keep going. Again, you equate this to px, polynomial x. Let's equate that. Let's do all of them like that. That was easier for us to know what we're doing. Px, all right. This one I equated to px. Okay. Yeah. Okay. So, you know what? Let's do the right side. So p -1 is what? It's equals to 2 times -1 squared plus, oh Lord, 5. I'm going too fast. It's 5 -1 plus 1. What is that? That is -1 times -1, it becomes positive. So it's 2 plus, I'm sorry, it's gonna be negative because let me see. Yeah, -5 plus 1. We don't want to go over. What is that? That is -2. Okay, that's it. We're done with that one. So we're basically done with that one. That's -1. You see that, right? So we did both. Is that -1 or no? I'm sorry, -2, not -1. Okay, so let's keep going. So we'll do the other one. We'll do the next one. This one is what is that? What do they want? Okay, we see the same thing. P2 is equals to, let me see, yeah, 2 is 2 raised to power 2 plus 5 times 2 minus 10. What is that? That's 4 plus 10 minus 10. Okay, so this cancels that. So basically this is 4. Okay, and then the other side, p -1 is -1 times 2 -5 -10. You see that, right? That's 1 -5 -10. So that's the same thing as -14. Okay, you see it, right? So that's -14. So let's go do the next one. Okay, this one is P2. What is that? It's -3 times 2 plus 14 times 2, negative 2. What is that? It's 4 times, it's negative. That's 4. 4 times 3 is negative 6. Plus, what is that? 28, negative 2. So that's negative 8 plus 28. So that basically this is 20, okay? See that, right? And then this one, P negative 1, okay? Is equals to negative 3, negative 1, 2, plus 14, negative 1 minus 2. Alright, what is that? Okay, this one becomes positive, so it changes nothing. Negative 3, negative 14, negative 2. You see that, right? That's equals to, see, all negative, man. So it's negative 19, man. You see that, right? That's negative 19, man. It's nothing else we could do. Negative 19. So we keep going. So we're done with that. So here P2 is equals to negative 2. Alright. 2, 5 times 2, negative 1. What is that? It's 4 times negative 2 is 8, negative 8, right? Plus 10 minus 1. What is that? That is negative 9 plus 10. That's 1, okay? P minus 1. What is that again? Negative 2. Negative 1 raised to the power 2 plus 5. Negative 1 minus 1. What is that? So negative 1 times negative 1 is become positive, but it changes nothing because the other one is negative. So negative 5, negative 1. See that? They're all negative, man. So that's negative 8. Okay, so that's what we got there. That's what we got here. All right. You know, so that's what we got, man. That's what we got. We got 1 and negative 8. Okay, so we'll move on to the next one. We'll do the next one. P2 equals to 2. Let me see. 2 times 2 raised to the power 5. 4, 2 raised to the power 4. Plus 5, 2 raised to the power 3. Negative 2 raised to the power 2. Oh Lord, that one is a high numbers, man. You know, so alright, see what I did? I just that's what you got there. So you simplify all that, okay? Alright, so that's what you got there. This cross out, this cross out, those two cross each other. So it's 14 minus 4. That would be 36, you see? That's what we got there, 36. Alright, the other side, what is that? P negative 1. Okay, this one will be a little faster. That's gonna be 2 times negative 1, 5, minus 4, negative 1 raised to the power 4, plus 5, negative 1 raised to the power 3, plus, what is that? Sorry, made a mistake there. You gotta substitute negative 1 raised to the power 2. Okay, notice that when the exponent is odd number, it doesn't change the negative number, but when it's even, it changes the negative number. So over here it doesn't change the negative, so it's negative 2. Minus over here is 4 times 1, because in the bracket the negative number changes, okay? And over here it doesn't change, so it becomes negative 5. Over here it changes, becomes negative 1. You see that, right? So that's that, that's that, that's that. So that's negative, what is that? 6, 7, negative 7. They're all negative. Negative 7, negative that. That is negative 12, man. So that's what is going on there. That's negative 12, okay? Alright. So let's do the last one. This one is P2 is equals to 2 raised to the power 4 minus 6, 2 raised to the power 3 plus 2 raised to the power 2 minus 2. Okay. Alright. So we'll simplify that. Alright, we'll keep simplifying. That's what we got there. 16, see, minus 48 plus 4 minus 2. Alright, so what is that? Alright, so that's minus 48. That controls everything, alright? So let's simplify that. Okay, that's actually, you combine the positive. Hang on a minute. Yeah, that plus that is 20. That plus that is 50. So yeah, it's negative 30. Okay, it's negative 30. That's what we got from there. Yeah, that's what we got from there. Anyway, so see what we did there. No, let's do the other side. I haven't done the other side, so let's do it. It's a P negative 1. What is that? You got negative 1 raised to the power 4, negative 1 power 3 plus negative 1 raised to the power 2, negative 1 over here, like that. So you simplify that. That will give you positive 1. That will give you negative 1 inside the bracket plus that. That will give you positive 6. Okay, so that will give you positive 1, and that will give you, it's like, remember that trick here? This is like negative 1 times negative 1. So that should be over there, that should be plus 1. So you add all that, see, it's all plus sign. You should get 9. Okay, so that's that there, man. Okay, in the following examples, we'll add the polynomials. You remember I gave you that example. If you have two polynomials, you can add them. The way you add them, you just add their coefficient. As long as the whatever you're adding has the same variable and the same, the same exponents, right? So it shouldn't be a problem. It's like you adding oranges to oranges, okay? As long as it's the same. There are several ways they do this, but it doesn't really matter. Look at that. You let me change the ink. You add that to that. See the same. See that? And this one, the same coefficient. You add that to that. You see that, right? So let's go. If you want, sometimes they write it like this: 2x raised to the power 2 minus 4x, and then you say you add this like that: 3x raised to the power 2 plus 2x. Sometimes they add it vertically like that. If that helps you, that's fine. You can do it that way. So you add the thing on the right hand side, add x to x. You get negative 2x. And then you got the one with the exponent is 2, right? You get, what is that? You get 5x raised to power 2. See that, right? I think we're done right there. See? Yeah, we're done right there. So that's how it goes. You can add it like that, and basically you're done. Or if you don't want to do it like that, another way you can do it like this. You can do it, let me see, you can do it like 2x raised to the power 2 minus 4x, and then you say add it to 3x raised to the power 2 plus 2x. You can add it like that. See, you add like terms. You see, remember we did that in the past. with other problems. You add like times, you get 5x raised to the power 2 minus, what is that? Minus 2x raised, yeah, no raise, the same thing. See, we got the same thing. So we'll move on to the next one. So we can do, let's do them vertically because it helps you to see clearly. Minus 5x raised to the power 3 plus 3x, and then you add this one here, 8x raised to the power 3 minus 4x. You see that, right? Just add that. What do you get? Negative x, and then that thing give you 3x raised to the power 3. See, you done. See that, right? So let's do the next one. I hope you see what we're doing, man. I'm just rushing. You see, right? We did it right, you know. So let's move on to the next one. This one here, you said 3x raised to the power 2 plus 5x plus, it's okay, this one got an extra. You see, it has extra over there too. It has a constant term, 2x, that's plus 2x raised to the power 2 minus 2x minus 4. Alright, you add those, add the constant, you get 2. You add the one with x variable, you get 3x, right? And then you add the one with x squared, you get 5x squared, okay? That's, let me see, I didn't put the sign. This is plus, and this is plus. You see it, right? Okay, so we're done with that one. We're done with it, man. Alright, we're done with it, so we'll rock and roll to the next one. We're done with that, man. Alright. So these are not really okay. This one, let me see. Yeah, it's okay. See this, let me see, I'm sorry. This one might be a little bit challenging because fractions are involved, man. You know, fractions will kill you, man. Okay, let me see. Yeah, this one may be a little bit more challenging. Okay, let's 2 over 3x squared plus 1 over 5x plus 1 over 6. Okay, you add this 1 over 2x, let me see, minus 1 over 3x plus 2 over 3. Yeah, it may be a little bit challenging, man, because we'll have to use our tricks here, you know. So yeah, see, we'll start with the constant term. The constant term is this one here. We'll start with that. Let's do it. So we're adding 1 over 6 plus 2 over 3, right? Okay, to add that, we'll do our trick. We said, let me see, oh man, alright, now we do trick in the other side. We want to get that to 6, so we say 2 times 2, that will get it to 6, so it's become 1 over 6 plus 4 over 6, so that would be 5 over 6, you see that, right? So if you add that, that would be 5 over 6. I'm sorry, I'm writing with red. Okay, so let me clear this and do the other one. That's all you gotta do, man. Do it slowly. That way you don't make any mistake. Alright. What is the other one? You just add the coefficients, okay? So 1 over 5 minus 1 over 3. You gotta raise them to the same denominator. You know, there's no need to show the work because we're using that as a scratch paper. We're gonna put both of them in 15. So we'll do 3 over 3. And over here we'll do 5 over 5, okay? So we'll get 3 over 15 minus 5 over 15, okay? So the same thing as, let's see, yeah, minus 5 over 15. Okay, so the same thing as negative 2 over 15, okay? So this one becomes negative 2 over 15x. Okay, so we'll do the last one. You know, it's a little bit more involved, but you take your time, do it right, don't worry about that. You know, so we're doing the same things with the same coefficient. We do 2 over 3 plus, what is that, 1 over 2. So we'll use our trick again. Denominator both of them have to be 6. So we do 2 times over 2, which changes nothing. 3 over 3, which changes nothing. So we do that, we get 4 over 6 plus 3 over 6, which is the same thing as 7 over 6. You see that, right? So this one is 7 over 6x raised to power 2. So we're done. You see it, right? Let's clear this one. Let's clear that thing up here. We're just using that side as a scratch paper. That's what we that's what we got right there, man. Did we mess up? We probably messed up somewhere. Oh Lord. I don't think we did it right. What did we do wrong, man? Oh man. Okay, so we keep going. I don't know. We did something wrong there. I don't know what we're doing. No, we didn't do something wrong. It looked like we do. Oh man. It looked like we did something wrong, but we didn't do anything wrong. We actually did it right. We did it right, man. Let me see. Yeah, we did it right. Okay, so let's do the next one. I was gonna say, how did we get that wrong? You know, it looked like we did it wrong, but you know. Anyway, let's do the next one. What is this? This is the same issue, man. So we align them up. We have 4 over 7x minus 1 over 5x plus 7 over, this is the constant term. You add this one here, 1 over 3x squared minus 1 over 3x plus 2 over 5. 2 over 5 right there. Okay, you see it, right? So let's do our trick again. We'll add the constant first. 7 over 9 plus 2 over 5. What is that? Oh Lord, this one gonna be involved, man, because we'll have to reduce that to the same, to a common denominator there. I think it gotta be 45, man. I'm telling you, it has to be 45. So 9 times 5 is what? 9 times 5 is 45, right? You know, because what happens is if anything fails, you do it like that. 9 times 5 is 45. Okay? And then 9 divide 5. I mean 9 divide 45. 9 divide 45, you get 5. Okay? 5 times 7 is 35. Alright? And then plus 5 divide 45, you get 9. 9 times 2 is 18. So you see what is going on there. It would be, that would be 30, no, that would be 43 over 45. You see that, right? Is that 53? Sorry. That would be 53, not 43, sorry. I dropped one off. 53 over 45, okay? So that thing, it will be 53 over 45. No mistake there. Alright, so we'll do the other one. We'll do the next one, the one with the x variable attached to it. We get minus, what is that? minus 5. We're just adding the coefficients. 3. Well, how do you do that? Okay, our trick will work here. We want to reduce it to 15. We'll do 5 times 5, 3 times 3. We'll multiply that out like that. Okay, so we'll get minus 3 over 15 minus 5 over 15. Okay, that will give you minus, what is that? Oh man, minus 8 over 15. Okay, so it's minus 8 over 15, right? Let me see. Yeah, 15 here, 8, yeah. Minus 8 over 15. Did I fuck up? Hang on a minute, man. Alright, 3, 15. What is that, bro? And 3, 15. Okay. Is that? Oh, I made it. No. There's no mistake here. Let me see. Okay. It's minus 8 over 15. So, just give me a. Let me see. Okay. Actually, I see my mistake. This is positive number here. Okay. And that's positive. So that will be positive. Alright, so you do that, that would be, if you add that, I copied the problem wrong. That would be, what is that? That's positive here. What is that? If you do, what do you get? You get negative 2. Yeah, negative 2 over 15, right? Oh, man. I think so, negative 2 over 15. Okay, negative 2 over 15. Now you do the other one. Let's do the other one. I copied the problem wrong. Okay, sorry about that. Let's do the other time is 4 over 7. No, I gotta use red. Consistent. Let's be consistent. 4 over 7, okay? Plus, what is that? 4 over 7 plus 1 over 3. Okay. So we'll have the same problem here. Let's do 7 times 3 is 21, right? 21, the same denominator. 7 divided 21, I think it's 3. See how it works out? You know, it's 3. Okay, 3 times 4 is 12. Okay, plus 3 divide 21, 7. 7 times 1, 7. So you keep going. That's 19 over 21, you see? So this is 19 over 21 x raised to power 2. Oh, this is x here. Sorry. You don't want to drop off the variable, man. You know, so, yeah, be careful. You don't want to, if you drop off the variable, then the answer is wrong. You know, so there's a reason why we're doing this, because eventually, when we get to something else, we're going to basically drop off the variable, do the manipulation, and then put the variable back. So that's why this exercise we're doing will help us. You see how we're doing it? It's like we're dropping off it. Think about it. It's like we'll leave the variables and then we'll add the coefficient, right? We'll add the coefficient. When we're done, we'll put the variable back. That's all we're doing there. So that will help us when we get somewhere. You'll see. Alright, now we're going to subtract polynomials. Alright, you can line them up vertically or you can do it horizontally. The first one I do with both, but the rest I will do it vertically. Okay, see subtraction, you line them up like that. So I'm going to do it two ways. You see, that's why I draw that wiggle red line. So you start subtracting, but be careful. This is not addition. So you subtract the like terms. Okay, minus 3, subtract minus plus 8. Don't forget that you got to change the sign. So it becomes it becomes minus, let's see, minus 30, let me see, minus 11x raised to power 2. And then you do the other one, 5 minus 2, it becomes 3 raised to power right there. So they were done. You see it right there. That's what we're looking for. We'll knock that one out like that. Okay. You don't want to do it that way. You can do it the other way. You can say 5x minus 3x raised to power 2. Okay. Minus 2x raised to power 3 plus 8x power 2. So when you remove the bracket, you will remove the bracket 5x3 minus 3x2 and then become minus x3 minus 8x2. You see that, right? So you're looking for the like term right there. It's 3x3 and then this term here becomes they're both negative. It becomes 11x2. So you get the same thing. Either way you like, it's up to you. Let's do the next one. See, subtraction and addition is basically you're doing the same thing. You just have to pay attention to the signs. That's all. 12x raised to power 4 minus x 2 minus plus x3 minus 8x4 plus 3x2 minus 3x. You see that, right? Alright, so we're subtracting. Now when you push the minus sign inside the bracket, the first one there, let me see, what did I do? I think there's a mistake. Yeah, I made a mistake. Yeah, see right here, you can't do that. The first one there, the one with x variable becomes plus. So you get 4x. Alright. And then the one that is squared, right? When you remove the bracket, it becomes minus. Right? And then you get minus 4x raised to power 2. This is plus, right? Okay. And then the other one becomes negative 8x raised to power 4. You add that to 12, it becomes 4. Let me see, 4x raised to power 4. That's what we're looking for there. Okay, that's what we're looking for there. I think we did it right. So anyway, I think we did it right, so let's move on to the next one. We'll keep moving on. So like I said, addition and subtraction are almost similar stuff. So we do that one. We'll say 13x 5 minus x3 minus 8x2 negative, subtract 7x5 plus 5x3 plus x2. Okay. Alright. So you see that, right? We're gonna do all that. So you pay attention closely. Look at the terms. The terms are the same. There's no mismatch. So like when you push the negative sign inside the bracket, everything there becomes negative, okay? So negative x squared plus negative 8x squared, you get negative 9. You cannot, I think you're supposed to draw that line, and negative 9x squared. Okay, negative x squared plus negative 5x, I'm sorry, not squared, negative x cubed plus negative 5x cubed. What do you get? You get negative, this is negative here, you get negative 6x cubed, okay? Alright. And then the last one is 13x raised to the power 5 minus 7x raised to the power 5. Okay, so what is that? That is what is left is let me see. What is left is 6, right? Yeah, what is left is 6 raised to the power 5. Okay, see, that's what we got right there. So we're knocking it out. So we'll move on to the next one. What? Oh, no, that's a mistake here. I made a mistake here. How did I do that? Oh, man. That's negative because I just looked at it, because this will be negative here. So, how can you get 9 if it's not negative? Okay. Sorry about that. I just catch that. I caught it with my eyes. Anyway, so let's keep going. This one here is 12 raised to the power 3 minus 8x raised to the power 2 plus 6x plus 7. There's a constant there. And we'll subtract the whole thing minus 3x raised to the power 3 plus 5x raised to the power 2 minus 2x, right? And 4. You know what we could do? If you want, another thing you could do, after you line it up like that, you can just remove that sign first. You can push the sign inside if that helps you, because you're subtracting. So let me show you. I can push the sign inside. Let me push the sign inside, show you what I'm talking about. So you push the sign inside, this one becomes plus. You push the sign inside, this one becomes plus, right? I push the sign inside, this one becomes minus. Let me show you. If we push it inside, that one becomes minus. If we push it inside, that one becomes, so I'm removing the brackets, yeah? That one becomes plus. You see it, right? So basically, I remove the bracket, then I add them. Now, instead of subtracting, I'm adding. Watch this. We're going to arrive at the same thing. 7 plus 4 is 11. Okay, you add the coefficients. That's 8x. And here you add the coefficient. That's negative 13x squared. Here you add the coefficient. That would be 15x cubed. Okay, so you can do it like this. This is plus here. I'm sorry, I'm not putting the sign. This is plus here. So you can do it that way if you like. If it helps you do it that way, because you end up with the same thing, man. You see what I'm saying? You're gonna definitely end up with the same thing. Let me see if we did it right. You gotta look at it carefully. See if we made a mistake somewhere. Sometimes I leave something off. No, we did it right. So yeah, you can tackle it that way if you want to, but don't make any mistake. Once you make a mistake, you're gonna have to try to catch it. It's hard to catch the mistake. You gotta have good eyes to catch it. So this one here is 5. Let me see. Just give me a minute. It's I want to make sure so everything is okay with it. All right. Okay, so we're subtracting all that. We're subtracting all that from the other one. Okay, so we'll subtract all that. It's 5x raised to the power 4 minus 3x raised to the power 3 plus 2x raised to the power 2. Okay, minus x plus 6. Alright, so we'll subtract this. Minus 6x raised to the power 4 plus x raised to the power 3 minus x raised to the power 2 plus x minus 1. You see that, right? That's what we said. So if you want, you can remove the bracket. You can remove the bracket this way. This one becomes plus. Okay, this one becomes minus, okay? And this one becomes plus. And this one becomes minus. Once you remove the bracket, it becomes minus. And this one becomes plus. So the bracket is gone. We remove the bracket. We don't need the bracket. We don't need that. So we just add the stuff. You add it. What do you get? This is 7. This is minus 2x. Okay. And this is 3x raised to the power 2. This is minus 6x raised to the power 3. And this is, let me see, what is that? That is 11x raised to the power 4. See, that's what we're looking for. That's it right there. That's what we're looking for right there, man. So you gotta be careful when you're removing the sign, the bracket. Make sure you're doing it carefully, noting everything. The sign that changed, the sign that didn't change. I think we did it right. I borrowed it. I don't see any mistake we made. So let's move on to something else. All right, now we're gonna multiply the polynomials. Okay. Now see, we're building this up slowly. We're building up a lot of stuff, the stuff we discussed earlier, so that's all we're doing. We're building it up slowly. All right. So let's do this. All right. So let's tackle the first one. You see, when you're doing multiplication, you're going to have to combine the exponents. You remember? That's why we took our time and did the exponents. We did that first. Look at that. You see all the. Look at all the. We're working with one variable, so look at all the x, their exponent. You remember when you multiply stuff, you add, right? So we took our time and did that thing, and did the exponents first. So that's basically like 3 times 2. Right, and then you combine the variable x raised to the power 2 times x raised to the power 3 times x raised to the power 1. You see that, right? So that can be 2 times 3 is 6, x 2 plus 3 plus. You remember the powers of exponent. You remember that? That's why we did that first. It becomes 6 raised to the power 6. I hope you see that, man. That's why I had to do exponent first. So this is polynomial. Polynomial can have any exponent up there. It can be 20, it can be 200. So when you're multiplying, it's different from when you're adding. When you're adding, you preserve the exponents. You add exponent. You add exponents like to like. Exponent that is squared, you find the exponents that are squared and you add them together. Preserve the square, right? But this time is different. You gotta multiply things out, man. All right. Okay. So let's tackle the next one. You see, the next one is with the same thing. We'll tackle it the same way we'll tackle the other one. Okay. All right. We isolate and then we'll combine. 4 times 2 times minus 1. You see that? X, right? X raised to power 3. 3 plus, I hope, let me do it this way. That way you don't get confused. 3 plus 2 plus 5. You see that, right? Okay, so you simplify that. That would be negative 2 times 4 is 8 times 1 is negative 8. And then x, you add all that up there. What do you get? You get, let me see, 8, you get 10. See that? So that's okay, man. You see? So when you multiply polynomial, it's a different beast, man. You gotta multiply everything. Let's do the next one. It's actually very interesting. It's easier to multiply if you master your exponents. Again, that's why I did the exponents first. Okay, so you have select 7 times 3 times minus 1. Okay, and then x, what is that? Did I put the bracket? Yeah, I did put the bracket on the other one. Then you put the bracket up there as 5 plus 4 plus 8. You see that, right? So when you multiply things with exponent, you add them. That's what they call the what rule is that? I think that's the power rule. No, that's not the power rule. That's the product rule. Product is when you multiply things out. So you do that. What do you do? 7 times 3, 21 times minus 1, negative 21, x, 5 plus, 4 plus 8 is 12, 12 plus 5 is 17. So that's it right there. You see it, right? It's actually, this one is even more fun, man. This one is a little bit more easier, more neater. You just follow the rules and you get it right. Alright, it's nothing to be scared. You just knock it out and go. Okay, let's do the next one. The next one is, alright, starting there. Okay, this is a little bit different. Americans call it for. You gotta use for, but all that means you multiply. When you remove the bracket, you multiply each thing out. Actually, there's no for here. You just remove the bracket. So you say 2x times 3x. You do the same thing over there. Alright. Plus, okay, 2x times 2. You see it, right? Multiply things out once you remove the bracket. Then it becomes, let me go from it, becomes 6x. Don't forget you're multiplying. So it will be squared plus 4x. Okay. Alright. And then I think we're done. I don't see how you can combine that. Let me see. There's no way to combine that again. You leave it like that. Basically that one is okay like that. There's nothing else you can do more. Okay, so you move on to the next one. That one, the same thing. You try to, remove the bracket. You get 4x, okay, times 5x plus 4x, okay, times 3. In case you don't see, you're taking, let me use a different ink. You take this. Once you remove the bracket, you multiply here, and then you take it, you multiply this one. That's what I just did. Okay, I hope you can see it. It's not that difficult. If you remove the bracket, you have to take that 4x and multiply the 2 times inside the bracket. And you get that. So you simplify, you get, what is that? 4 times 5 is 20x squared. Plus, what is that? 12x. You see, right? I think I'm done there. See? So that's what is going on there, man. This one is a little simpler to handle because we did the exponent. Let's move on to the next one. 3x times negative 2x raised to power 3, okay, plus 3x 4x raised to power 2. Alright, see it, right? Okay. So you keep moving on. What is that? That is negative 6x raised to power 4. You see that, right? Alright, plus what is that? 12x raised to power 3. You see it, right? Because basically we did there's 1 here, there is 1 here. You add those two, you get 4. You get 4 here. You add those here, you get 3 here. Add that and add that, you see? So that's our solution there. We're done with that one. I don't see anything you could do. You couldn't do more there. You could, depending on what you're doing, you could remove the 6 outside, put a bracket, but it's not necessary here. It's not required, So let's move on. Okay, let's try to do a couple of more multiplication examples. You see that there, what is given to you there, the first one, you have, you see how they write the polynomial is, they didn't write it in standard for me, but it doesn't matter. I'm talking about the polynomial inside the bracket, but it doesn't matter. So we'll multiply things out. We'll have, now what you do is you take the whole thing there. That time you multiply that, then you use it, you multiply that, then you use it, you multiply that. That's the plan, okay? So you use it, you multiply each thing inside the bracket, and you add them up. So that is a 2, I'm sorry, I don't want to write with red pen, let me remove that. That is 2x raised to the power 4 times 6 plus 2x raised to the power 4 times 5x plus 2x raised to the power 4 times 3x raised to the power 2. You see it, right? Oh Lord, I hope I have space. I write so big I might not have space, man. You simplify. That is 12x raised to the power 4 plus 10x, right? You gotta combine powers. That's 1 up here. 10x raised to the power 5. Man, you see why it's good we did exponent, man. Alright. 6x, what is that? 6x raised to the power 6. Okay, so we'll see if anything can simplify. See, they have different, it's all different exponents, so there's really nothing can simplify. I think we're done with that. Look at it carefully, there's nothing else to simplify. So it's 12 raised to the power 4, 10 raised to the power 5, 6 raised to the power 6. There's nothing else you can do. You can't combine them because, so we're done with that. That's the solution there. So it's good, we'll preserve the space. But we may not be lucky next time. I write so big. Anyway, let's do this one. We'll do the same thing. We'll multiply each time inside the bracket with the time outside. We'll get 4 minus 4x raised to the power 3, right? You see, let me see. Yeah. So we multiply and we'll get minus 7x raised to the power 2. Okay. And then we say plus minus 4x raised to the power 3 multiply 8x, okay, plus minus 4x raised to the power 3 multiplied by negative 9. Be careful. Try to put the plus signs and then what about the brackets? Eventually, when you remove the brackets, you use the appropriate sign because you're gonna multiply anyway. You will see what I'm saying in a minute. So you leave that there like that, leave that there like that, and then we'll see. Let's multiply. Now you see, when you multiply this, you get positive sign. You see, you get positive result, right? You can see it there. So you don't want to confuse yourself. Just use bracket wisely. Bracket should help you to deal with all that stuff, okay? So be careful, and then you do that. That's plus 28x, you see, raised to the power 5, okay? And then the other one will be negative. because you see negative times positive. You see it there, right? You know, so that's why you gotta be careful. That's 32x raised to, this is 1 here, raised to power 4. Okay, the other one is gonna be positive because you multiply negative with negative. Okay, look at it carefully, you see what I'm saying. And that will be positive 36 raised to power 3, because this one got no variable. So let's see what we can. Basically we're done. You see, I'm sorry, where is x? X is right here. Sorry. What did I do there? I dropped off x, man. Let's clear that. I don't know what I did there. Okay, you see, so I don't see anything. There's nothing else to combine, so we're done. That's the solution there. It's nothing else we can combine. 28 raised to power x raised to power 5, 32. What did I do, man? I thought that is 32. Where did I write 3? This here is 32, man. You see, I think I'm getting tired, man. That's 32. What the hell did I get 3? 32x raised to power 4. Okay, see, I'm getting tired, so it's probably about time to quit. So I think we did this right now, but let me be a little careful. That way I can finish up. When I finish with this problem, we just quit. Next time we'll start where we stop. No big deal. So we multiply this out. What do you get? You get negative 9x raised to power 5. Alright. And hang on a minute. That's alright, so we'll keep going. We're doing good. Times negative 3 raised to power 6. Alright, plus negative 9 raised to power 5 times negative 2 raised to power 4 plus, alright, negative 9 raised to power 5 times 8 raised to power 2. So you see, that's how I like to do it. So I'm struggling with the negative sign. You just put everything inside bracket and use a plus symbol, and then when you start combining them, negatives will cancel each other. If it doesn't cancel, it will be negative, you see. So you know, so that's the way I like to do it. Okay, so this is you see, negative times negative, you get 27. What is that? Those two, you gotta add those together. You get x raised to power 11. You see that, right? Now this is gonna be positive, so plus, right? You see that, right? Yeah, make sure you see that, man. So that's 18 raised to power, see that, you add that, that's 9 raised to power 9. This is gonna turn out to be negative, so negative, you see that, right? Make sure you see that. Okay, so that's gonna be negative 72x, see that, you add that, that will be 7. Okay, see, there are different variables, so I mean the exponents, so there's really nothing anybody can do there. So it's 27x raised to power 11, 18x raised to power 9, negative 72x raised to power 7, and we did it right. So we'll move on to the next one. Okay, alright, the next one is there. What is that? Okay, this is a new format. Before we multiply with one term outside the bracket, now we got 2 terms. We got 3 terms in one bracket, 2 terms in the left bracket. So Americans call it for. They use for. All that means you take this. Oh, so let me change the. You take that, you multiply this, and you multiply this, and you multiply that. While you go in, you add them. And then when you do that, you do the same thing with the other one. You multiply this with 1, multiply that with 1. You're multiplying all the times, you see. So I will show you. Just pay attention to what I'm doing. The way it's done is 6x times, I like to put everything in bracket, 2x squared, okay? Plus 6x times 4x, all in bracket, plus 6x times 1, okay? And you keep going, you add the rest of the stuff. 1 times 2x, right? Yeah, 1 times 2x, basically it's 2x. 2x squared. Then 1 times 4x plus 4x. 1 times 1 plus 1, you see? That's all they're saying there, man. Then you combine stuff. Okay, combine stuff. What do you have? You have 12x raised to the power 3 plus 24x raised to the power 2 plus 6x plus 2x raised to the power 2 plus 4x plus 1. So when you done multiplying, it's likely you will have the zero. This one will combine with that. That will combine with that. You see that, right? So you say 12x raised to the power 3 plus, you combine that and that. Okay? You get 26x raised to the power 2, and then you combine this and that. You get 10x, and then plus 1. I think we're done. If we were careful, we should have gotten it right. But let me check myself, see if I messed up somewhere. I don't think so. I think we did it right. Oh man. So let me see if I messed up, left something unwritten. I think I wrote everything down, so I think it's okay. So we'll move on to the next one. So I wanted to do a couple of that type, this type here. That way you see how it's done, this type here. I wanted to do a couple of that, a couple of it more. So you see that one is that type too. So you see how it's done. You take that, the first time you multiply everything, you add them as you multiply. You take the second time, you do the same thing, you add as you multiply. That's all. So let's do it. It will be 9x times 9x squared. You see it, right? Okay. Plus 9x times x plus 9x times 1. You see it, right? And you keep going. Now you do with 2. Okay, you do with 2. What is that? 2 times 9x plus 2. 2 times x and plus 2, because 2 times 1 is 2. So you simplify. Okay, you see it, right? Yeah, make sure you see what I'm doing. See, what multiply what. So this is 81x raised to the power 3. See why I did the exponent first. So when you multiply these two, you gotta add the exponent. So you get exponent 3. So you do the same thing here. 9 times that, you get 9x. You add the, because 1 is here, 1 is here, it becomes 2. Plus 9x plus 18x raised to the power 2 plus 2x plus 2. Okay. You see how things break down. Now you gotta add the like terms. This one is by itself. This one adds to that one. This one adds to this one. And that one is by itself. So let's do it. So you say 81 by itself. Okay, what is that? 9x plus 18x. What is that? That's 17x raised to power 2. You see, right? When you're adding it, not you don't do anything to the exponent. You're just adding the like terms. Okay, the other one is 9 plus 2 is 11x. And then you bring that 2 here. Is there anything else to add? I don't see anything. I think we're done. Let me check. I think I did it right. No mistake there, man. I see when I'm hurrying up is when I make mistake. But if I do it slowly, usually it comes out right. So no, I think there's a mistake somewhere. Hang on a minute. Where did I get that? Okay, that's right. Let me see. Hang on a minute, man. That's a mistake. I find my mistake. Just give me a minute. Okay, so this times that, you get that. This times that, you get that. This times that, you get that. Okay, so what is x? Where is this? Is 9. See where I fucked up? I dropped something off. I dropped that. I dropped 10. You see it, right? I dropped 10. I knew something was wrong. 18 plus 9. It's 27. It's not 17. Okay. So, but anyway, yeah. So always check your work. Make sure you didn't drop off something by mistake. I think we're done with that. That one is good. Let's move on to the next one. I think it's the same thing again. Yeah, I want us to do a couple of these. That way you get hang of it. So let's do this again. This time I'll be a little careful. So when you start getting tired, you start making mistakes. Alright. So we do the same thing. We use what Americans call for. Say 9x times 8x raised to power 2. Not that. You can't do that. Plus 9x times negative 6s. See how I'm doing it? Don't worry about the negative. Just do it like this, and then it will work itself out. 9x plus 9x times 1 is 9x. And then you continue. You start with this one. Plus negative 2 times 8x. Okay? Plus negative 2 times negative 6x. Okay? And then one more plus negative 2 times 1, and you leave it like that. So let's simplify. I hope you see that. You see it, right? Check it out. See if I skip something. I don't think so. I didn't skip anything. So this is 72x. Yeah, this is where I normally leave stuff behind. Let's not do that now. This is negative 54x. Hang on. See, I'm getting tired. This is 3. See, I told you. Alright, because 1 is here, you gotta add them. 1 is here, 1 is here, you gotta add them. Okay, plus, what is this? It's gonna be negative. Okay. No. Hang on a minute. It's not negative, it's plus 9x. Okay. Negative 18. Oh man. It's not 18. I think I'm getting tired. Negative 16. 16x. And positive 12x, negative 2. Okay, so you gotta combine. This is by itself. Combine that, and then combine that and that. This is 72x. Okay. What is that? It's a 50, 60. It's actually 70x. You see it, right? Yeah, 70x plus 21x. Alright, minus 2. I don't think there's anything else we can combine. I think we did that perfectly okay. We did that. We did that. Okay, I might have dropped something. Okay. Now what is that? 72x. Yeah, I think we did it okay. So let's do the last one because I'm completely exhausted. This one is a little bit easier. This is 2x times, let me see, 2x times 3x squared plus 2x times 4x, okay, plus 2x times negative 4, okay, and then we'll do the other one. Okay, we'll do negative 1, that's plus negative 1 times 3x, okay, plus negative 1 times 4x, plus negative 1 times negative 4. See it, right? So let's simplify things a little bit. We'll combine that will give you 6x with exponent 3 plus 8x exponent 2 negative 2x, no, not 2x, it's 8. Sometimes that thing acts like that. Negative 8x, okay. Alright, the next one is negative 3x squared. The next one is negative 4x. The next one is positive 4. You see it, right? So this one by itself, we'll combine this and that, we'll combine this and that, okay? 6x, 3. Let me see. We'll combine those two, we get 5x squared. And then the other one is negative, what is that? 12x plus 4. See it, right? Okay, that's what I got there, man. I don't know. I have to check it, see if I left something behind. Let me see. I think we didn't leave anything behind. I think we did okay. Yeah, we didn't leave anything behind today. Please subscribe to my channel, like and share this video. If you have any question, leave it under the video. I will get to them as soon as I can. Please, thanks for coming. I will see you in the next video.